So today you're going to be working on the composition of functions, and you did take some notes on this yesterday in your function notation, but I want to go over it a little bit more for today. So for today's functions, we're just going to use f of x is 3x plus 5 and g of x is x squared minus 2. So your equations can be all kinds of different variables, g, f, all that stuff. Your equations can change depending on what it says in the problem itself. So this first problem says f of g of 1. It's kind of like you say the word of every single time you get to a beginning of a parentheses. So it's a function of g of 1. So as I said yesterday in my last notes is you work from the inside out. So the first thing you're going to do is figure out the answer of g of 1. So it's important to make sure you're using the right equation. So I'm going to use my equation for g, and I'm going to plug in the number 1. So I'm going to do 1 squared minus 2. So 1 minus 2 is negative 1. So the answer to g of 1 is a negative 1. So using that answer, I'm now going to plug negative 1 into the equation for f, because my next layer of my equation is my f equation. So what I'm now finding is f of negative 1. So if I take my negative 1 and plug it into my equation for f of x, f of negative 1 is now 3 times negative 1 plus 5, which is negative 3 plus 5, which is 2. So that means that my final answer for f of g of 1 is a 2. Now you have to make sure you are careful again about your order, because on number 2, I switched it around. I did g of f of 0. So if I start on the inside, the first thing I'm going to find is f of 0. So I'm going to make sure I use my f equation, and I'm going to plug an x in, a 0 where x is. So I'm going to have 3 times 0 plus 5. So 3 times 0 is 0, plus 5 is 5. So that means that f of 0 is a 5. So now I'm going to find g of 5. So I'm going to take my 5 and I'm going to plug it into the g equation. So it's going to be 5 squared minus 2. So 25 minus 2, which is 23. Okay, so let's try one more, because I want to show you again this notation. This word, this little symbol, it kind of looks like it says fog, but it's not. It's the word composed with. Composed with. So it is f composed with g of negative 2. Now the order stays the same. So f was first, then the g, then the negative 2. So if you just add parentheses around everything, those two are the same. So f was first, then the g, and then the negative 2. So f composed with g of negative 2 is the same as f of g of negative 2. So just like the previous ones that we are going over, the first thing we're going to do is figure out g of negative 2. So we're going to do negative 2 squared minus 2. Now be careful, if you plug this into your calculators, you're going to have the parentheses like I just wrote. Otherwise, your calculator is going to give you the wrong answer. So negative 2 squared means negative 2 times negative 2, so that's a 4, minus 2, which is a 2. So now I'm going to plug that 2 into where my f equation is. So I'm going to now find f of 2. So I'm going to do 3 times 2 plus 5, so 6 plus 5 is 11. So my final answer for f composed with g of negative 2 is 11. Now sometimes, as I said in my last video yesterday, they're not going to give you a number. It's just going to say an x. So it's telling you to plug one equation into the other. So let's see what this one means. So g of x, I don't have a number. All I know is that the equation for g of x is x squared minus 2. So I replaced my g of x with its equation. So instead of writing g of x, I wrote x squared minus 2. Well, if I want to find f of x squared minus 2, what that's telling me is take x squared minus 2 and plug it in where your x value is. So that's going to get me 3 of x squared minus 2 plus 5. So I have my 3 right here. And then I plugged in my x squared minus 2 where my x would have been. And then we have the plus 5. So if I want to simplify this, I'm going to do some distributing. So let's distribute. So 3 times x squared is a 3x squared. 3 times negative 2 is negative 6, and we have that plus 5. And if I finish combining my like terms, I have 3x squared minus 1. So f of g of x is 3x squared minus 1. Now I wrote this one with the composition little circle on purpose. So g composed with f of x is the same as g of f of x, same order. We're basically going to take the f of x function and plug it into the g of x function, because the f of x function is 3x plus 5, and we now need to plug that into the g equation. So our g equation is an x squared, so instead of an x, we're going to write the 3x plus 5 squared minus 2. Now there's a very specific reason I chose this problem, because of something you learned in Algebra 1. Squaring something means multiplying it by itself. So 3x plus 5 squared literally means 3x plus 5 times 3x plus 5. We still have that minus 2. That matters because we're going to have to do super distributing. You might have heard it called FOIL, super distribute, something like that. So 3x times 3x is 9x squared. 3x times 5 is 15x. Then 5 times 3x is another 15x. And 5 times 5 is 25. And we still have that minus 2. If we combine all of our like terms, so 9x squared, there's no other x squared term, so it's its own type of term. We have a 15x and another 15x, so that is a 30x. And then we have a 25 minus 2, which is 23. So that is our final answer for g composed with f of x.